So let me tell you a story that sounds like science fiction, but isn't. In November of 2018, a scientist named He Jiankui stood up at a genetics conference in Hong Kong and told a room full of the world's top geneticists that he had done something no human being had ever done before. He had edited the DNA of two human embryos, twin girls, before they were born. He claimed he was trying to make them resistant to HIV. The room went dead silent, and then it went furious, because what He Jiankui had done wasn't just unprecedented. It was the one thing the entire global scientific community had essentially agreed you do not do. You don't edit genes that get passed down to future generations. You don't make permanent changes to human DNA that echo forward through every descendant those children will ever have forever. And he did it anyway in secret, without proper oversight or informed consent, and then announced it at a conference like he expected a standing ovation.
And I want to be absolutely crystal clear about something before we go any further. What He Jiankui did was reckless, arrogant, and unethical, and he deserved every consequence he got, including the prison time he served. Nobody in the scientific community defends what he did, but here's what always gets lost in the outrage over that story. The technology he misused, CRISPR gene editing, has also done something genuinely miraculous. And I don't use that word lightly. Let me tell you about a woman named Victoria Gray, because her story is the other side of this coin, and it might be one of the most beautiful things modern science has ever accomplished.
Go ahead, because I actually think her story is every bit as important as his, and we need both of them side by side to understand what we're really dealing with here.
Victoria Gray lived in Forest, Mississippi. She had sickle cell disease, which means her red blood cells were shaped wrong, literally misshapen, crescent-shaped instead of round, clogging her blood vessels, and causing pain that she once described as being stabbed with knives from the inside out. She'd been hospitalized over and over her entire life, sometimes for weeks at a time. She couldn't hold her own children some days because the pain was too much to bear being touched. In 2019, she became the first person in the United States to receive a CRISPR-based gene editing treatment for sickle cell disease. Scientists took her own cells out of her body, used CRISPR to edit the genetic error that had tormented her since birth, and put the corrected cells back. And the pain crises stopped. Not managed with medication, not reduced to a tolerable level. Stopped. She went back to work. She held her children without wincing. She slept through the night for the first time in years.
And that story honestly gives me chills every single time I hear it, because it's not abstract. It's not theoretical. It's a real woman with real children who got her life back because of a technology that didn't even exist a decade earlier. That's extraordinary.
And Victoria isn't alone anymore. That's the part of this story that keeps getting bigger and more incredible. Dozens of patients have now been treated for sickle cell disease and beta thalassemia with gene editing therapies. The FDA approved the first CRISPR-based therapy in late 2023. This is not experimental fringe science happening in someone's garage. This is approved medicine, going through the same rigorous regulatory process as any drug on the market, and it is working. People who spent their entire lives in agony are waking up without pain for the first time. If that's not a miracle, I genuinely do not know what the word means.
And here's the distinction I need everyone listening to understand, because it is the single most important line in this entire conversation. What they did for Victoria was something called somatic gene editing. They changed genes in her body, in her existing cells, and those changes stay with her. They do not get passed to her children. They do not ripple forward through future generations. Think of it like editing a copy of a document on your computer without changing the original template file. What He Jiankui did was something fundamentally different: germline editing. He changed the template itself. He altered DNA that will be copied into every single cell of those twin girls' bodies and then passed to every child they ever have, and their children's children after that forever. Those are two radically different things, and the entire conversation about gene editing falls apart the moment we blur the line between them.
And I completely agree with that distinction, which is exactly why I get so frustrated when people use He Jiankui's recklessness to argue against the entire field of gene editing. Because right now, there is a broad and deeply held scientific moratorium on heritable germline editing in humans. The global scientific community looked at what He Jiankui did and responded with overwhelming, near-unanimous consensus: never again. Not until we understand the consequences far better than we do today. That's not a scientific community racing toward designer babies. That's a community that polices itself more aggressively than almost any other professional field I can think of. One rogue scientist broke the agreed-upon rules and was sent to prison for it. That's the system of guardrails working, not failing.
And if the story ended right there with Victoria Gray healed and the moratorium holding firm, I'd honestly be the biggest CRISPR cheerleader on the planet. But it doesn't end there, and I think deep down we both know it. Because the exact same molecular tool that fixed Victoria Gray's sickle cell gene could theoretically be used to edit genes associated with intelligence, or athletic ability, or physical appearance, or any number of traits we might decide we want more of. And the moment we go from fixing a disease to enhancing a trait, we've crossed a line that we absolutely cannot uncross. That's not medicine anymore. That's designing human beings to specification. And once someone opens that door, even just a crack, market forces and human ambition will kick it wide open.
So here's where I want to push back, because I think the slippery slope argument, while emotionally powerful, assumes a level of technological inevitability that just isn't supported by how the science actually works right now. Today, editing a single well-understood gene for a well-characterized condition like sickle cell disease is at the very edge of what we can do reliably. Traits like intelligence or athletic ability aren't controlled by one gene or even 10 genes. They involve hundreds or thousands of genetic variants interacting in incredibly complex ways that we barely understand. The leap from fixing a single mutation to designing a smarter baby is not a small step on a slippery slope. It's a canyon we don't even know how to cross yet and may never fully bridge.
And I hear that and I respect the scientific nuance, but I'm not talking about next year. I'm talking about the trajectory, the direction we're heading over decades. Right now it's sickle cell. 5 years from now, it's eliminating gene variants associated with early onset Alzheimer's disease. That sounds great, right? Compassionate, even. Nobody's going to argue against that. But then it's reducing genetic predisposition to obesity. Then it's adjusting for height. Then it's optimizing cognitive function in ways we'll call therapeutic because we've redefined the baseline. Each individual step feels like a small, reasonable, compassionate extension of the last one. And before you know it, we're living in a world where wealthy parents are choosing their children's traits from a catalog. The slope isn't hypothetical. It's the most predictable pattern in the entire history of technology.
But let me ask you something genuinely uncomfortable. Where exactly do you draw your line, and who is suffering on the other side of it while you're drawing it? Because right now today, a child born with cystic fibrosis is facing a lifetime of devastating lung infections, repeated hospitalizations, and an average life expectancy that is still tragically short despite decades of improved treatments. If we develop a somatic gene therapy that fixes the underlying mutation in that child's cells, are you really going to look that child's parents in the eye and say, "I'm sorry, we could cure your kid, but we're worried about a theoretical slippery slope that might materialize 20 years from now," because that's not caution. That's condemning a real person to real suffering over a hypothetical future you're afraid of.
And that is exactly the kind of emotional framing that makes this conversation so dangerous, because you can always find a sick child to justify the next step. Always. I am not arguing against curing cystic fibrosis. Let me be absolutely clear about that. I'm arguing that we need ironclad international governance frameworks before we go much further down this road. And I'm pointing out the uncomfortable historical fact that we have never once, in the entire history of human civilization, managed to build that governance before the technology outran it. We didn't do it with nuclear weapons. We didn't do it with social media. We didn't do it with fossil fuels and climate change. The idea that this time, with a technology that literally rewrites the fundamental code of human biology, we're going to get the regulation right on the first try, that's not optimism. That's wishful thinking, dressed up as responsible policy.
So your position boils down to this: because we failed at governance before, we should let children continue dying from diseases we now know how to cure. Because that's the actual math you're doing here, whether you want to frame it that way or not. Every year of delay, every year of hand-wringing in committee meetings and international summits that produce beautifully worded documents and zero actionable policy, is measured in real children who didn't have to suffer but did. I'm not asking for a world without rules. I'm asking for a world where we cure the diseases now and figure out the enhancement boundaries in parallel, because the people dying from sickle cell and Tay-Sachs and muscular dystrophy cannot wait for us to build the perfect regulatory framework from scratch.
And I'm asking who gets to decide where the line between curing and enhancing actually sits, because I promise you that line is nowhere near as bright and clean as you think it is. Is eliminating a genetic predisposition to clinical depression a cure or an enhancement? What about reducing severe anxiety? What about boosting immune function beyond what we'd consider normal human levels? Every single one of those sounds like compassionate medicine, until you step back and realize you're fundamentally redesigning what it means to be a baseline human being. The therapy enhancement distinction looks beautifully clean on a whiteboard and falls completely apart the moment it makes contact with reality.
Alright, let me address the elephant in the room head on, because there's an argument against gene editing that I actually think is even stronger than the slippery slope, and it's the one that keeps me up at night more than anything else we've discussed. It's about money. The first CRISPR therapy approved for sickle cell disease costs approximately $2.2 million per patient. $2.2 million for one single person. And here's what makes that number even more painful: sickle cell disease disproportionately affects Black communities, who are already the most underserved, most underfunded population in American healthcare. So what we've done is build a miracle cure for one of the most devastating genetic diseases on Earth, and then priced it so that the people who need it most desperately cannot afford it. If that doesn't make your blood boil, you're not paying attention to who this technology is actually serving.
Thank you for making my argument more powerfully than I ever could have myself, because this is precisely what I mean when I talk about the future of gene editing in a world driven by markets and profit. The technology is going to be genuinely transformative. I have no doubt about that. And the benefits are going to flow overwhelmingly to the people who can write the check. We are actively building a world where the wealthy can edit disease out of their entire family line across generations, and everyone else gets to watch from the sidelines. And here's what terrifies me most: once those genetic edits compound across generations, you don't just have economic inequality anymore. You have biological inequality. A genetic upper class whose descendants are measurably healthier, stronger, more resilient, and more disease-resistant by design. That's not a metaphor for a class divide. That's a literal, physical, scientifically measurable divide written permanently into human DNA.
And that vision genuinely terrifies me every bit as much as it terrifies you. I'm not going to sit here and pretend otherwise, but here's the counterpoint, and I really need you to sit with this for a second before you respond. The first complete human genome sequence cost $3 billion and took 13 years of work by thousands of scientists. Today, less than 25 years later, you can get your full genome sequence for under $200 in about a week. That's roughly a 50 million-fold reduction in cost in just 2 decades. Gene therapy costs will follow the same curve. They always do with biological technologies once the initial breakthrough is made. The $2.2 million price tag is a first-generation number for a first-of-its-kind therapy. And using it to argue against the entire field is like looking at the first commercial cell phone in 1983, which cost $4,000 and was the size of a brick, and concluding that mobile communication will always and forever be a luxury product for the rich.
Except that in the decades between the $3 billion genome and the $200 genome, people suffered and died from conditions that earlier access could have prevented. The cost curve eventually drops, sure, it always does, but eventually is a timeline measured in human lifetimes, and the people who fall into that gap, the ones who needed the cure before it became affordable, are always the exact same people: the poor, the marginalized, the communities that were already being systematically failed by the healthcare system long before gene editing ever entered the picture. You're asking them to trust that the market will eventually bring the price down, and the market has given them absolutely no reason, zero historical precedent, to believe that promise will be kept.
And that's precisely why I'm not arguing for the market to sort this out. I'm arguing for the opposite: public funding on a massive scale, government-negotiated pricing from day one, international aid programs and manufacturing agreements that make these therapies accessible to every patient who needs them, regardless of their ability to pay. because you're absolutely right. If we leave gene editing to the free market alone, we will end up with your biological aristocracy. The solution isn't to ban the technology or slow it down until the world is fair. The solution is to fight like hell to make sure this technology belongs to everyone from the very beginning.
And I want to believe in that vision. I genuinely, sincerely do. But then I look at insulin, a drug we've had for over 100 years, a drug that costs almost nothing to manufacture, and people are still dying in America right now today because they can't afford it. They ration their doses. They skip meals to pay for vials. They die alone in their apartments with empty insulin pens on the nightstand. The institutions that would need to ensure equitable access to gene editing are the exact same institutions that have catastrophically failed at equitable access for everything else in medicine for the last century. You're betting the future trajectory of human evolution on the hope that this time, somehow, the system will work differently.
And you're betting that the alternative, doing nothing, waiting, is somehow better. So I have to ask you directly, what is your alternative? Keep the technology locked away until the world is fair. Because the world has never been fair, not once in all of human history. And waiting for it to become fair before we cure genetic diseases is really just another way of saying we're comfortable with children continuing to suffer as long as the suffering is distributed equally. I reject that framing completely. I would rather spend my energy fighting for universal access to a cure that exists than mourning the absence of a cure we were too cautious to develop in the first place.
So let me try to find the ground we actually share, because I suspect there's more of it than the intensity of this conversation makes it seem. I believe CRISPR is one of the most important discoveries in the history of our species. Full stop. Victoria Gray's story makes me hopeful in a way that very few things in this world do. But I also believe with equal conviction that we are not ready for what comes next. The governance frameworks don't exist. The cost and access structures don't exist. The international consensus on where to draw the line between treating disease and enhancing traits doesn't exist. And history tells us, with brutal and unbroken consistency, that we will not build those things before the technology outpaces them. So I'm not saying stop. I'm saying slow down just enough to get this right, because the stakes here are literally encoded in human DNA, and mistakes made at the genetic level don't wash out in a single generation. They echo forward forever.
And here's where I come down on it. I believe somatic gene editing changes made to living patients that do not get passed to their children should be pursued with everything we've got for every genetic disease we can target. I believe germline editing changes that pass to future generations should remain under a strict enforceable moratorium until we have international governance structures that are genuinely worthy of the power being wielded. And I believe that cost and access are the single biggest ethical challenges we face in this space, bigger than the slippery slope, bigger than the enhancement question, the fundamental question of whether we build a world where the cure for genetic suffering is available to every human being who needs it, or only to those who can afford a $2 million treatment. But through all of that, I refuse to let the perfect become the enemy of the miraculous. Every month we spend deliberating, someone like Victoria Gray is spending another night screaming into her pillow because her own blood cells are tearing her apart from the inside. The moral weight of that suffering sits on our shoulders every single day we choose not to act.
I think you and I are going to be having this exact argument for the rest of our lives. And honestly, I think that's exactly how it should be. Because the moment either one of us wins this debate completely, something critically important gets lost. If your side wins without my caution, we get a world that moves too fast and leaves the most vulnerable people behind in its wake. If my side wins without your urgency, real people continue to suffer from diseases we knew how to fix and chose not to, out of an abundance of caution that they are paying for with their bodies. The tension between us isn't a bug in this conversation. It's the safeguard. The argument itself is what keeps this technology honest.
I'll drink to that, same time next week.
Same time next week. Bring better arguments.
Bring better bourbon.